of a discrete random variable. This problem is about a consumer electronics store that sells alarm clock radios. The store always has 4 radios in stock. So at the beginning of each week, there are 4 radios, and if they sell some of these radios during the week, then they bring the in-stock level up to 4 at the end of the week. But at the beginning of the week, there are always 4 alarm clock radios. Okay, so they want that I saw that I answered several questions. They give me some information more. For example, they give me that the radio sells for $30 and costs the store $18. So we can compute, for example, the profit. They are getting a profit of $12 per clock. And they also give me this table, and this is the table of the probability distribution of the weekly demand for the radio. Okay, for example, we see here that the weekly demand could be between 0 until 6. So never there is a demand of 7 clocks. So at most 6 clocks. And they tell me, for example, I learned here that the 3% of the time the demand is 0. So there are some occasions when they don't sell any clock. Or sometimes the demand is 0.077% of the time. That means that the 7% of the times the demand is 1. Or 12% of the time the demand is 2. So these are the possible value of the demand. Never 7, never 8, at most 6. And with this information, they want that I compute what is the expected weekly demand for the alarm clock. Also, what is the expected weekly profit from the sale of the alarm clock? And on average, how much profit is lost each week because the radio is not available when demanded. And that happens sometimes because if the demand is 5 and there are only 4 clocks, so they are losing the sale of 1 clock. So they are losing a profit of $12. Or sometimes when they are selling, the demand is 6, but because they have only 4 clock in stock, so now they are losing the sale of 2 clocks. So they are losing a profit of $12. So sometimes there is a loss, and they want that we compute the average of this loss. Okay, so let's compute, or let's solve the first question. What is the expected weekly demand for the alarm clock? And they are telling me this is a random variable, yeah, because they are asking me to compute the expected value of this weekly demand. And we have a formula for the expected value. The expected value, remember, is the expected value of the variable will be equal the sum of the product xpx. So I need to multiply the value times the probability of the value and add together at the end when I have all the products. So for that reason, it will be a good idea to have another column with the product xpx. So we have the x here, the ps here. So the demand will be, the weekly demand will be the variable x. The probability of x is given here. So let's make another column. If I make another column with the product xpx, so I need to find here what is the product of 0 times 0.03. 0 times 0.03, the answer is 0. Okay, 0. I type here 0. 1 times 0.07, the answer is 0.07. Good. 2 times 0.12, the answer is 0.24. I type here 0.24. Then 3 times 0.22, 0.66. Let's type 0.66. 4 times 0.44, this is 1.76. Let's type here 1.76. 5 times 0.08, this is 0.40 or 0.4. Let's type 0.4. And 6 times 0.04 is 0.24. If I add together all these numbers, I get the expected value. So please use the calculator to add 0 plus 0.07 plus 0.24 plus 0.66 plus 1.76 plus 0.4 plus 0.24, and I get 3.37. So 3.37 will be the expected value. What does it mean? That in average, the expected weekly demand is 3.37. Maybe that's the reason why this store has only 4 alarm clock radios in stock every week. Yeah, because they know that they expect to sell between around 3 clocks. Yeah, obviously, what that means also that if in average they sell the weekly demand is 3.37. Okay, so let's see how to answer the other question. What is the expected? Let's type here first the answer for the first question A. So it's 3.37, the expected weekly demand. Okay, now question B. What is the expected weekly profit? So if we want to compute the expected weekly profit, we need to construct the probability distribution of this new random variable, the weekly profit. Yeah. So will be a table like the first one that we have, but instead of the weekly demand, we're going to have the weekly profit. If we do that, we have here the weekly profit, and we need to construct also the probability of each of the possible profit. So if we want to construct a probability distribution of a variable, we need to find all the possible values of the variable. In this case, the variable is profit, so we need to type here all the possible values for profit. The profit could be 0, and could be 0 because sometimes the weekly demand is 0. Nobody wants this radio this week. So for that reason, you sell 0 clocks, and then the profit is 0. So I'm going to type this as a possible value of a profit. Another value of the profit will be 12, and that happens when you sell 1 clock. Yeah, so I'm going to type here 12, maybe 24 because you sell 2 clock, so will be 24 or 36 or 48 in the case. Oh, but you notice that never is 60, and never is 60 because you need to sell 5 clocks to have a profit of 60, but you have only, or this store has only 4 clocks in stock. So for that reason, so this will be the maximum profit, 48, and this 48 is when they sell all the 4 clocks that they have. Okay. So what are the probabilities? The probability of selling 0, of having a profit of 0, it will be that nobody comes to. So it's the same probability of a weekly demand of 0. If the demand is 0, they don't sell any radio, and for that reason, the probability of that, the probability of that is the same of the probability of 0, and the probability of 0 is 0.03. So I mean, this is the probability of having 0 profit. The probability of having a profit of 12 is the same the probability of having of the demand was only 1. There was only 1 person that wanted the radio, and for that reason the profit was 12. So the probability is 0.07. The probability of having a profit of 24 is the same that the probability of having a weekly demand of 2. So there will be 0.12. The 3 will be 0.22. But in this case, the probability of having a profit of 48. When you have a profit of 48, when the demand is 4, obviously, but also when the demand is 5, because if the demand is 5, you have only 4 clocks in stock, you're going to sell 4 only. The same here. So actually, the probability of selling 4 radios is the same of the probability of the demand was 4 or more than 4, because if the demand is more than 4, you are going to sell only for radios. Yeah. So for that reason, to find the probability of a profit for 48, I'm going to add probability of 4 plus 0.08 plus 0.04. Yeah. So the probability, this probability will be 0.48, 0.56. Yeah, 0.56. Good, 0.56. So to see if we are doing the things well, we need to add together all this, and the answer must be 1. So add together all this number, and the answer is 1. So we have a correct probability distribution. If we have a probability distribution, then we can compute the expected value. The only that we need to do is multiply the values times the probability. In this case, I'm using another letter y. I don't want to be confused with the other variable. Yeah? This variable is symbolized by the letter y, so it will be the value times the probability, and this y will be the profit. Yeah? So I need to make another column again, the values times the probabilities, and here will be 0 times 0.03, the answer is 0. 12 times 0.07, the answer is 0.84. I type it here. Now 24 times 0.12, use your calculator, the answer is 2.88. 36 times 0.22, the answer is 7.92. And finally, 48 times 0.56, the answer is 26.88. To get the expected value, the only thing that I need to do is just add together all this value, and I get the expected value. And this will be the expected value for the profit. Less 0 plus 0.84 plus 2.88 plus 7.92 plus 26.88. The answer is 38.52. So means that I can answer the second question. The expected value for the profit will be $38.52. So that means that in average, the profit that I get for selling these alarm clocks every week is 38.52. So we have the average sale for the selling of this alarm clock. Okay, so now let's solve the next question. On average, how much profit is lost each week because the radio is not available when demanded? Yeah? So focus in this. Okay, now we're gonna find, so we need, when they say on average, this is another way to say what is the expected value. But the expected value of the profit that is lost each week because the radio is not available. And when the radio is not available, when the demand is 5, there is one, is the demand is 5, they have only 4 radio, there is one radio that is not available. And sometimes when the demand is 6, there are 2 radios that are not available, that were demanded, but they were not available. So I'm going to make another table and another probability distribution for the loss. Yeah. So I'm going to write here the loss. What are the possible loss? Maybe there is no loss because most of the time there is no loss because in all these situations there is no loss. They sell what people want. Yeah? If the people want 1 clock, they sell it. If the people want 2 clocks, they sell it. So sometimes the profit is 0. Sorry, the loss is 0. Sometimes the loss is $12, and that happens when the demand is 5. They lost $1, the sale of 1 clock. Yeah? And remember, we are finding the expected value of the loss if the radio is not available. Yeah, if there is 1 radio not available, there is a $12 loss. Sometimes there are 2 radios that are not available, and in this case the loss is $24. And now the probability of each of these things happen. So the probability of, let's call it Z, this variable, the probability of Z. The probability of 0 when there is no loss. In all these cases, there is no loss. Yeah? If the demand is 0 or less, I cannot say that something was not available. Yeah, no, there is no lot for that. So is the probability of having of the demand is 4 or less will be the probability of a loss of 0. So when there is no loss in all this situation. Okay, let's find this probability. It will be the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. If you add together all this probability, the answer will be 0.88. Let's see, 0.88. Yeah. So in this case, there is no problem. There is problem here when there was a loss of one radio that was not available, and this happened with the probability of 0.08, and there is a loss of $24 for not having available two radios, yeah, and this happened with the probability of 0.04. So this is the probability of not having available two radius. So adding together all this probability, the answer must be 1 if we are doing well. Let's do it. So the total is equal 1.88 plus 0.08 plus 0.004. Okay, now we have this probability, and now we need to compute, yeah, the expected value. And remember, if we are going to do the same, multiplying the value times the probability. So I'm going to do this, and in another column, 0 times 0.88 is 0, 12 times 0.08 is 0.96. Let's type it, 0.96. 24 times 0.04 is 0.96. Let's type it, 0.96. And then add together, and 1.92 is the answer. That means that is a $1.92 that we expect we are gonna lose. We are gonna lose every week for not having this the radio, for not having available the radio. Okay, so that means that in average the loss for not having available the radio is $1.92 per week. Okay, so that concludes my explanation of this exercise, and that is actually a good exercise for practicing the computation of the mean or expected value. Okay, thank you.